Today we will see about the silicon control rectifier. Okay, so you have to see about the silicon control rectifier. Silicon control rectifier is also termed as thyristor. Okay, so here we will be studying about the different devices, different power semiconductor devices which are used for various purposes. Okay, so in this here the name itself, okay, here name itself you are having the term, it is control rectifier. Okay, so control rectifier means you are normally in the rectifier circuit we will be using the diodes. Okay, so when we are using the diodes we will be having a uncontrolled output. Okay, so by replacing the diode by the silicon control rectifier, or by replacing it by this one thyristor, you will be getting a controlled output. Okay, so here comes, this is your circuit. Here this will be your circuit diagram for the symbolic representation, not circuit diagram. This is the symbolic representation of your silicon control rectifier or thyristor. Okay, so how many terminals it is having? It is having the positive anode terminal, the negative cathode terminal, and you are having a control signal as the gate terminal. Okay, so here you are, it is a 4-layer junction, 4-layer device. Here you are having PN, 4-layer device, and we are having 3 junctions. The junctions are J1, J2 and J3. The current flow, what about the current flow? The current flow will be from your anode to cathode, that is positive to negative. You will be having the current flow. Okay, so here we'll see about the various modes of operation, how you can connect the thyristor. So you can connect the thyristors by here you are giving the two possibilities of there. One is what, your anode, it can be connected to the positive terminal. Second one is anode can be connected to the negative terminal. Okay, when your anode is connected to positive terminal and cathode, here what about here cathode is connected to the negative terminal, what will happen? Your junctions J1 and J3 will be forward bias. Junction J1 will be forward bias, junction J2 will be forward bias, but the J3 will be forward bias, but this junction J2 will be, what about this one, this J2 will be reverse biased. Okay, and this is the second case condition when you are connecting the anode to the negative terminal, that is anode is positive terminal. Okay, so this is connected to the negative terminal, and you are connecting, what about here, you are connecting the positive terminal of the battery to the negative terminal of the device. So in this case also, this is these both junction J1 and J3 will be reverse bias. Okay, so based on these connections we are having the different modes of conduction. Okay, so in that, your first one we are having the forward blocking mode. This is the first case what I have told. Okay, so without applying the gate signal to your, we are not applying the gate signal, only the positive terminal is connected to the anode and negative is connected to the battery, then the junction J1 and J3 are getting forward bias and junction J2 will be in the reverse bias condition. Okay, so this is termed to be the forward blocking mode. Okay, so this condition is termed to be forward blocking mode, or it is in the forward bias mode. So during this condition you will be having the, will be having a small current. Okay, will be having a small current, which is termed small leakage current, will be flowing through the SCR during this condition. Okay, during the forward blocking mode. Second case, we are having the forward conduction mode. In forward conduction mode, again what you are doing in here, what you are doing here, you are not applying the gate signal. The same condition, the positive is connected to the anode and the negative terminal of the battery is connected to the cathode, and we are increasing the supply voltage. So once you are increasing the supply voltage, what will be happening? The avalanche breakdown. What about here? The avalanche breakdown will takes place. Once this avalanche breakdown is taking place, what about that? Your device will be in the forward, the forward breakover voltage will be occurring. Okay, so once this forward breakover voltage is occurring, your device, the device is said to be, the SCR will be said to be in turned on condition. SCR is said to be turned on condition, and this mode of conduction is termed to be, the forward conduction mode. Okay, So this is the first case when we are connecting the anode to the positive terminal of the battery and cathode is connected to the negative terminal of the battery. Okay. So one case is when we are applying, we are having a small leakage current. Second case, we are not applying the gate voltage, gate terminal we are not applying any control signal, but again what you are doing, we are increasing the supply voltage. So once you are increasing the supply voltage, what will happen? Avalanche breakdown will be taking place. Okay. The same condition, if you are applying the gate signal, your conduction will takes before the value. Suppose if it is the voltage, the forward conduction drop is in 1 or 2 volt, means it will takes in 0.5 or zero point 0.7 volts once we are giving the gate voltage. Okay. So this is the second case of the diagram. When you are reverse biasing, positive terminal is connected to forward conduct, positive is connected to the negative terminal of the battery and cathode is connected to positive terminal of the battery, means it is reverse bias. Both the junctions are reverse bias, but J2 will be getting the forward bias. Okay. So this even in this condition also we will be having a small leakage current will be flowing through the SCR. Okay. So these are the three conditions. So with this we can go for the this one by VA characteristics of your SCR. Okay. So here you will be having, so once the breakover voltage is happening, after that your conduction will start increasing. Okay. So here this is in the reverse breakdown voltage. Okay. So reverse breakover voltage. So here in SCR, the in the various modes of operation of the SCR, and also here the device, once you are giving the gate signal voltage to the gate signal, your device will be turned on. But even though we are removing the gate signal, your device will having any no control over the gate. The gate will be having no control over the device. That means your device will be in on state. Still the device will be in on state. Here we are having two parameters. One is your holding current and one is your latching current. This is the minimum value at which the current keeps on going on increasing. Latching current is also the before, once the value is before the latching current, your device will be on. But if it is going below holding current, your device will be turned off. Okay. So this is about the SCR. It is used in various applications where we are in switch remote power supplies, in uh, speed control of uh, speed control of the induction motors. Okay. So these are your power devices. We can use it for the various applications. Okay. So that's all about the SCR. Thank you. Thank you all.